Okay, so parallel lines. So this is titled parallel lines, but it kind of has a lot to do with angles. So first of all, we're going to establish what parallel lines are. So we come across parallel lines a lot in everyday life. So if you look at a train track, and pretend I'm drawing this really neatly, this line is parallel to this line because it has exactly the same steepness. These lines are parallel to each other. So, how in maths do we write that something is parallel without writing the word parallel? How would we know? So if we have two lines that are parallel, the way they do this is they put an arrow on this one and an arrow on that one. And that symbol there, the arrow, basically denotes that these two lines are parallel. So these tell you, okay, so we know what a parallel line is and how to find one, like what it looks like. So I'm going to run through some theory and then we're going to do 3 exam questions. Okay, so we have 3 types of angles that we can sort of work out from knowing that lines are parallel. And we have a zangle, a fangle and a cangle. Not a cankle, cangle. So this is the useful ways to remember them. So let's look at a Z angle, a zangle. It does have a proper name, which we will get to. So let's say if we just draw out a Z for zangle, basically these 2 lines have to be parallel. So we denote that with that. So we've got 2 parallel lines here and here. So they could continue. You've got a line that sort of, goes across. So there's your Z in the picture. And a zangle basically means that this angle here, A degrees, is the same size as this angle here. Now this has a better name. Well, to be honest, I think it's a worse name, but it has another more mathematical name. So zangle is helpful for recognizing what it is, but it's also called an alternating angle. So within some exam questions we'll see an example of a zangle. That's what it looks like. What about F? So here is my F. I'm just going to adapt this bit. So these 2 lines are parallel for this to work. So remember, we are always dealing with parallel lines. So they could extend this way, and we've got this line that crosses it, and it kind of makes an F. So let's say all these lines are attached, but you can kind of, if you've got good eyes, you can see that there's an F in there. Okay, so what does a fangle tell us? What useful things can we get from this? So a fangle tells us this angle here, A degrees, is equal to this angle here. So if you see an F looking thing in all your parallel lines, then you can use fangle. And this is called a corresponding angle. So let's move on to C. So let's create a C with our parallel lines. So a C would look something like this. And remember, we're dealing with parallel lines, so these 2 are parallel, and they have to be denoted with this arrow, otherwise they're not parallel. So that's how you know. But these lines might be extended. So what can we know about a cangle? So basically, a cangle tells us this angle here, which I'm going to call A, and this angle here, which I'm going to call B, so they're not the same, and it tells us that A plus B equals 180 degrees. So that's what a cangle tells us. So if you see a C in your diagram, that is what you can use. Now we can actually prove that works, because if we think about it, if we use our fangle knowledge, so here we have an F, so the F is there. So we can see a fangle in this shape. So a fangle would tell us this angle, this A, is the same as this one here. So we know that this is A. Now if we just zoom in to this section here, we have a straight line there on a bit of an angle. Now what do we know about straight lines? We know that a straight line, the angle all the way around is 180 degrees. So this actually confirms that this A plus B equals 180. So yeah, we've just shown how, because this is A, from our fangle knowledge we know this is A, and this is on a straight line, so we know that A plus this angle here, which we've called B, has to add up to 180. Another important bit of theory is, so if we look at these 2 lines here, they're parallel, which is denoted by, and that is, if you have this angle here, let's call it A, this angle here opposite is the same size And then due to a fangle, so if we look here, so if I do it in small, in mini here, so I'm looking at this section, and we've just been told that this angle is A, and that these two lines are parallel. Therefore we know from the fangle rule that this is also A, so this is also the same size, so this is size A, and then we also know from this rule that the opposite one is A. So what about the angles left? So if we look here, and we call that B, we know that from the rule that the ones opposite each other, so this is A, so this is A, opposite, then this is B. Okay, now looking at this here, we have a fangle. So if I write this bit out in mini, so these two lines are parallel, and we know this is B. Therefore we know from the fangle rule that this is also B. And from the opposite rule we know then this, because it's opposite, is also B. So now we know all the angles. And we know from the Kangle rule that this, here's your C, so we know that A plus B equals 180 from the Kangle rule, here and here. But we can also confirm that because we know that A and B on a straight line equal 180, so we know that A plus B equals 180 from being a straight line as well. So we know it from a Kangle and we know it from a straight line. So let's now move on to some exam questions. I'm just going to write over here the name of the angles and then their mathematical name so we can refer back to it. Okay, so I forgot to mention in the theory section, but a Kangle, a C angle, is actually, its proper term is an allied angle, and I kind of think of that as they're kind of allies working together to get the 180 degrees, so A plus B is 180. Okay, so this first example says find the angle Y and explain how, and it's given us this diagram. So the first thing we note when we see this question is that we have these symbols here, so we know that the lines are parallel, so we know we're probably going to have to use the Zangle, Fangle or Kangle. So now we know sort of which part of our GCSE knowledge we need, we're going to try and find which one to use. So we're looking for this angle and these two lines are parallel, and we've been given 2 bits of information. What I can see here is our first example of a Zangle, and these two lines are parallel. So there we can see our Z. So what did our Z tell us? It told us that the angle here is the same as the angle here, and we've been given this angle here, so we know that this angle Y is equal to 64 degrees. Okay, and it's asked for an explanation as to how, and it's a bit unprofessional to write Zangle. So what you would write is alternating, and that's how you do that question. So that's you can kind of see there how it's easy to spot a Z when you just write out the Z, but that is seeing the Z within a bigger picture is probably the harder part. Okay, so this is the next example, and we have find X and Y and find Y and Y. Find Y and Y. So first thing to know, I then see the diagram and I notice that it has these 2 arrows. So these 2 arrows tell me the lines are parallel, so I know that I'm looking at angles and parallel lines, so I'm probably going to have to use my Zangles, Fangles, Kangles rules. So let's have a look at what we can see. So first of all, what I would do, my advice for tackling these questions isn't necessarily just focusing on the angle you want, but maybe just writing some angles that you can see working just to get some more information. Here I have a parallel line and here I have a parallel line. So here I can see I have an F. So an F tells me that this angle here is the same as this angle here. But can I work out that angle there? Yes, I can, because this is a straight line, and I already know 85, and a straight line has to equal 180. So if I do 180, take away 85, that should give me that angle there. That is 95 degrees. So I know that this is 95 degrees now, and I also know that this is 95 degrees now. Therefore I know, which I could have seen earlier, but I saw a different F, I know that that is then a straight line, so it adds up to 180, or I could have seen it like this, and seen this F. So from Fangles, I know that this angle here is the same as this angle here, even though it's looking quite messy. So I know that's 85, and this is 85 degrees. And that is from knowing Fangle. So I'm just going to write Fangle here, just so I can remember when it asked me how I got there. Okay, so that's 85, and we've got that bit, and we notice that y is on a straight line, so I'm just going to blow that bit up. So therefore I know that y is, so y plus 85, because it's on a straight line, equals 180 degrees. So I know that y is 95 degrees. So I'm looking at x, and I can see here that I also have another f. So if I make that bigger, I've got this, and these two lines are parallel, and this is x here, and this is 150 there. So therefore I know from my Fangle rule, because that's that x is equal to 150, and then I'd write, instead of writing Fangle, because it's a bit unprofessional, my reasoning would be corresponding angles. Okay, so what about the reasoning for y? And here we would write our reasoning Okay, so this is our final example, and we have to find x. So first of all, we've only been given one angle, so the first thing I would do is kind of notice that it's got these arrows here. So it's telling me they're parallel lines, and I'm looking for angles, so I know I'm going to have to find zangles, fangles, and cangles. So the first thing I can see here is a z, so dum dum dum, so the zangle, where these two are parallel, and I know that one. That means I also know this one, so this is my z. And I know that from alternating angles, this angle here is the same as this one. So I know that is 38 degrees. So the way I would write this in exam is quite formally. So I might say, I know that angle AED, so this stands for angle AED, ED, equals 38 from, and then instead of writing zangle, you write, okay, what else do we know? So we notice also that it has these funny lines here, and they don't just, they're not just going to put them in for no reason. So those lines mean that the triangle is an isosceles triangle, but those lines actually mean these two lines are the same length. And we know that if two lines in a triangle are the same length, which is denoted by that, it's an isosceles triangle, and the two base angles here and here are equal. So if that's angle A, that is also equal to A. So therefore we know that this is an isosceles triangle because it's got these two that are the same length, so two angles are the same. And if you can see, if you spin that triangle, you get this type of situation. So the two angles at the base, being this one, let's call them A and A, are the same size. So I might write that as my next sort of thought process. So we know those two are the same size. We also know, next thought process, that angles in a triangle sum to 180 degrees. So that means if you add up all the interior angles of a triangle, they equal 180. So this is our triangle, and what do we have? We have 38 degrees plus A, they all add up to 180. So now we know we can get rid of, actually you should probably label A because we put A in there. Next thought process, so nearly there. I'm trying to find x and I know this one, so we've got a line here. Said it was a straight line in the question. Angles on a straight line add up to 180 degrees. So we know this total bit is 180, but we only want the x bit, so we've got 180, we've got x plus this angle is a straight line, so equals 180. So x equals 109 degrees. And there is, as you've written your thought processes as you go through, we've found x and we've said y because we've put down every single step.